In this video, our objective is to demonstrate the process for performing a two-way ANOVA random block design experiment. This example illustrates 25 patients that were treated for chronic Achilles tendonitis by using heavy load eccentric muscle training. The table below provides tendon thickness data before and after treatment. Because we are looking or examining data before and after treatment for 25 randomly selected people, this is considered a paired experiment where the patients are considered as blocks, and we will use Excel's two-way without replication method to answer the questions below. Before we get to those questions, basically we have the data. Here's 25 patients, and this is their tendon thickness before and after treatment. The questions we're being asked are what experimental design was used or is going to be used, and it's randomized block design. We have two treatments, before and after thickness, and we have 25 patients. Those are the blocks. Okay? The question we're being asked to do is give the null and alternative hypothesis for determining whether the mean tendon thickness before treatment differs than after treatment. So I've written it as the null, the mean or the mu, after minus before treatment is 0, and the alternative hypothesis, mu after minus before treatment differs from 0. And then of course we're going to want to know if we reject or do not reject the null hypothesis. So in order to do this, we're going to hit data. Go to data analysis. Again, here we have three different ANOVAs that we can choose from. This one is two-factor without replication. We have one data point, if you will, one before and after per patient. So that makes it without replication. We're going to hit OK, and let me clear the fields. So we start fresh. So right here, we're going to capture the entire 3 columns of data. We're going to, I'm going to put my output right here. I'm going to click OK. And so what Excel gives us is it gives us a summary for the 25 patients, or the 25 blocks, the fact that we have 2 data points before and after, a sum, an average, and a variance. And then if you come down here to the bottom, you'll see a before and after thickness row. And I'll just come back here and I'll just highlight it. And basically what it is telling us is, one, we have 25 data points, which is consistent with the fact that we have 25 patients. And we see that the before thickness is about 9 millimeters compared to the after thickness of about 7.7 millimeters, and that reflects the 25 patients. So when we do our hypothesis testing, we want to know if this difference is statistically significant. So here, down below, we have our ANOVA table, which really gives us our source of variation. What I like to do is, since Excel gives us rows and columns, I like to type next to rows, this is our blocks. Our columns are our treatments, before and after. And in order to determine if we reject or don't reject the null hypothesis, we come over to this p-value right here that's associated with the treatments. For that is what we're trying to understand. Is there a statistically significant difference at an alpha of 0.05? As we can see here, alpha, or excuse me, the p-value, it's much less than 0.05, which says we would reject the null hypothesis, meaning that there is sufficient evidence at an alpha equal 0.05 that the mean tendon thickness before, or excuse me, after minus before treatment is indeed different than 0. That concludes this video.